Welcome to the University of Michigan Dentistry Podcast Series, promoting oral health care worldwide.
Cohesive gold restorations are made by the placement of filling golds directly into cavities that have been prepared with retentive form. These direct filling golds have cohesive properties. These golds are usually used in areas where there is conservative loss of tissue, where the carious lesion has been rather minor. The first restoration that will be completed will be a Class 1 in the buccal pit of a lower molar. The type of cohesive gold or direct filling gold that will be used here will be of the wrought or fibrous type. The Class 5 preparation, which will be completed second, will utilize the alloyed filling gold, a gold which has greater density to it, a gold which is not 100% pure gold, but rather is alloyed with a calcium. This is also a conservative preparation which will take a particular form which we will be discussing later. The Class 3 restoration will also utilize the alloyed cohesive gold, utilizing principally a lingual insertion, a lingual approach to the prepared cavity, and the insertion of the restorative material. This produces an aesthetic restoration. Aesthetic certainly compared to the older Black's design of preparation that we see on the slide with the exposed labial surfaces. These cohesive gold restorations, even though they are aesthetically unacceptable, have shown nearly 60 years of service. The variation of the Loma Linda preparation, again, will be utilized for the Class 3 restoration and employing the alloyed cohesive gold. We have referred to the various forms of cohesive golds or direct filling golds. The fibrous foil that will be used in the Class 1 preparation comes to us in a rope form. This is a container that is larger than you receive, but one that is used at the dispensing desk. We see that the rope form of this material, the rope being developed really from essentially a 4 by 4 inch square sheet of material of pure gold that has been malleted, annealed, malleted again and again to form the very thin sheet. Each of these ropes contains 2 grains of material. Each of these ropes is formed from a very thin sheet of the gold foil material, such as you see here. Some older practitioners prefer to roll the ropes themselves from these sheets. Again, the ropes that you and I receive are of a consistency that is rather fragile. You can see perhaps the pieces from the rolling of the sheet as I take this apart with the end of a carrier. Eventually, we will be cutting the rope into small segments, then taking these small segments and rolling them between clean fingers to form little spheres that are easier to pick up, anneal, and carry to the prepared tooth. The alloyed filling gold, which is alloyed with the calcium, is a crystalline type of material. It is called electroalloy by trade name. It is a more dense material and comes in a ribbon form, the crystalline material being within the ribbon, and then the ribbon covered over with some of the fibrous cohesive gold that we've just seen previously. Again, this material is cut into sections and used then carried through an annealing flame, placed in the prepared cavity, and again condensed. Two other forms of cohesive gold that are in common use include matte gold and encapsulated powdered gold. The matte gold is a crystalline material similar in nature to the alloyed filling gold. This is, however, a pure gold, again in crystalline form and coming in various widths of strips. We would take a portion of strip and view it, see that indeed it is, we try to break it apart in a fine crystalline form. It's a group of crystals really that are compressed together lightly in the form of the strips. This then is cut into pieces and annealed in an open flame to bring it to a cohesive state so that it can be condensed and exhibit the coherence. Encapsulated powdered gold, or gold dent, comes in the form of small pellets of the pure gold that really contain the powdered gold wrapped in a layer of the fibrous material. If we would take a hold of one of these and break it down, we see that within the fibrous covering is the powdered material. Again, this material is quite dense in nature and has been used extensively in recent years as a direct filling gold. When the cohesive gold ropes are cut into small pieces, we see that we get a pile of the small pellets of the fibrous foil, really this pile equaling essentially 3 of the 2-grain ropes of material. And these two materials are of the same density. When we look at the other forms of the foil that we'll be using, we'll find that there is indeed a difference in density of these materials. We see here then the 3 2-grain ropes of foil, an equivalent amount of the fibrous foil that has been cut and rolled into small pellets, these really being of a 1/128th size. An equivalent weight then of the electroalloy, of the matte gold, and of the encapsulated powdered gold. These last 3 then are of a greater density and are used essentially for bulk filling. The fibrous foil with the lesser density used in the more conservative preparations, and again this is the reason why we will use it first for the Class 1 buccal pit. Before using any of the cohesive golds, they should be annealed. The annealing process is really a cleansing process in which heat is used to drive off volatile materials from the surface of the gold. There are 2 methods in common use for annealing the cohesive golds. One is the piece method, which each piece of gold is taken one by one through an alcohol flame, and the second, the bulk method. The alcohol flame that we'll be using for the piece method of annealing should be lighted with the match held below below the wick. The wick then adjusted so as to form a small blue inner cone. A piece of foil then is taken by the carrier and is slowly passed through the flame till there is the first change in color, the first glow or reddening of the piece of gold. Carry this through carefully and see that first change in coloration. Now if we would dim the lights in the room, perhaps we can show that glow better. We'll take another piece of foil and carry it slowly through the tip of the cone to watch for that momentary glow. We should observe the glow, but yet not a movement of the metal, since this movement of metal would indicate a change in the physical character of the material and a potential loss of cohesiveness. The pieces of foil that we have been annealing in the alcohol flame have been a result of cutting of a number 1/2 rope into various sized pieces. If we would take essentially a quarter of this rope and cut into 16 equal pieces, this would give us a number 1/128 size pellet. Each of these pieces is picked up, rolled into a small pellet, then semi-condensed, if you will, and deposited to the sides within easy grasp then for annealing. Now we have a little larger pellet, a number 64 pellet. You see, if we try to attach these together, there is a lack of coherence at this time. If we would take these into the alcohol flame and anneal, let's set this one down to the side and now anneal another to bring about the coherence of the material. See, now as we would touch these together, there is that physical characteristic of coherence that is developed. We have been using the alcohol annealer in the piece method of annealing. Earlier we have mentioned the bulk annealer, and we see the electric gold foil annealer here in front of us. As we look at the top of the annealer, you see the pieces that are laying here separated. If we take a piece of the gold and from that area touch it to its neighbor, you see that there is a coherence of the material. If we move to the back portion of the annealer, we see one of the problems that can develop unless care is taken, where these particles, or rather pellets of foil, are placed together in large groups rather than separated. There is a tendency for these, as they do heat and become coherent, for them to stick together, and they're difficult to manage. So we've seen then the piece method of annealing and the bulk method of annealing. The annealed cohesive gold is brought to the prepared cavity. In this case, we're utilizing the electroalloy, which is a bulky, rather dense material. It is attached first to the mass of material already present, and then condensation brought about by a sustained, heavy, and a rocking type of a force. Each time the instrument is moved, it's moved approximately 1/3 to allow 1/3 of the previously condensed area to remain, and moved along in a stepwise fashion. Again, a force that's directed from the center out towards the walls of the prepared cavity. A sustained, forceful condensation pressure. This is a condensation that will bring about the objectives of condensation. Those objectives of condensation really being 5 in number. We are welding together the pieces of gold as we bring about the condensation. We're adapting the golds to the walls and to the margins of the preparation. And in this condensation, we're gaining a uniform compactness, or reducing the voids, air voids between each piece and within each piece. As we bring about this condensation, we're also cold working and to some degree hardening the metal. We're developing strength within the entire restoration itself, a type of tensile strength that brings and holds the mass together. We have now condensed this piece. There's a slight excess that's up near the margins. We'll just take this excess and move away from the operating field. So this is the hand pressure condensation then with the more dense material, the electrolyte. When condensing the fibrous gold foil, the annealed piece is brought to the prepared cavity and attached to the surface of the gold that is already present. And then the condensation will take place using a sharp malleting type of a blow. This is not a hard blow, but a distinct sharp blow to bring about the attachment of the piece of metal and its condensation and cold welding to the entire mass of material. The stepping of the condenser takes place, this overlapping. And again, the type of blow is one that should not be injurious to the tooth and its supporting tissues. It is really a type of blow that if one would do this at the end of the thumbnail, that there'd be no discomfort involved in that type of a tapping action. So this is the type of malleting blow that'd be used for the cohesive gold foil. Similarly, another type of condensing instrument is an automatic condenser. It's a malleting type of blow, but the malleting takes place automatically by depressing the condenser tip with a bit of pressure behind it, a tripping of a spring, and the malleting action occurring in this fashion. And this provides for a little greater ease on the part of the operator in bringing about this type of condensation with the cohesive gold foil. Again, the cohesive gold foil being less of a dense material, the malleting type of blow used to bring about its condensation. Another form of condensation which is similar to the hand malleting is the use of the Hollenbeck pneumatic condenser. The condenser handpiece is really actuated by air pressure from a small motor within the unit. The frequency and the intensity both of the blow can be regulated with this instrument. The McShirley electromallet is another form of blow-type condensation. This is a high-frequency type of condenser, speed variation, frequency variation of blow on up to 3,600 times per minute. It again delivers a less intense but still a forceful condensation to condense the fibrous gold foil. In order to better show condensation, we have taken a class 5 on a bicuspid, cross-sectioned it, and are looking now at this cross-section view of a partially condensed foil. The electrolyte has been driven into the retentive areas at the cervical, which is to the left of the screen, and to the occlusal to the right, and a piece of foil now added to the cervical area to demonstrate the type of condensation or direction of condensation that should occur. The condensing instrument is placed into the central area, and the condensation force occurring, again, driving the material into the retentive area and against the cervical wall. This is continued all across the cervical area until the condensation is complete in this area, a piece then would be laid to the incisal wall, and similarly the area condensed, directing the condensation forces against this incisal, or in this case the occlusal wall. In summary then, with the Class 1 preparation, we'll be using the fibrous cohesive gold and hand malleting condensation. For the Class 5 preparation, and when electrolyte is used, we'll be using the sustained hand pressure condensation, and in a similar fashion the same type of condensation with the electrolyte for the Class 3.
You've been listening to a presentation from the University of Michigan School of Dentistry, which is dedicated to supporting open learning and open educational resources. This recording is licensed under the Creative Commons. It may be reused and redistributed for nonprofit use. Please attribute materials to the University of Michigan School of Dentistry and redistribute under this same license. For more information on how this and other University of Michigan School of Dentistry recordings may be used, visit www.dent.umich.edu/license.